Hello, my name is Ivan Novick, and I'm very happy to be here in Korea. And I am very impressed by the great companies that you have in Korea. And my hope to come here is to give you more software and more tools to help your great companies do more great things and to make a huge global impact with what you can do with software and with data and with AI. So in this presentation, I will introduce for the first time Greenplum version 7. It's our newest version of Greenplum, and it's our platform for enterprise analytics from business intelligence to artificial intelligence. So let's get started. So Greenplum is a unified platform. It unifies intelligence. Intelligence from simple intelligence to complex intelligence, from business intelligence to artificial intelligence. And it allows you to transform your business and to transform your data into action. Because at the end, there needs to be an action in order to get some business value from your data. So we help you to transform that raw data, all of your data, terabytes of data, gigabytes of data, or petabytes of data, and help you transform it into insights that can produce action. So let's get into the product information. Now, this product, you can think about our architecture. We have a core architecture and then a extension ecosystem. So at the core of Greenplum is the Postgres technology. The Postgres technology is an open source and advanced relational database technology that is extensible. And Greenplum 7 now introduces 5 new versions of Postgres. 9.5, 9.6, 10, 11, and 12, and it introduces 87,000 new code commits into Greenplum from 6 to 7. Now, Greenplum is already a proven platform. It's not a new technology. There are over 500,000 CPU cores running Greenplum around the world every day. And those are running across billions and billions of queries and producing complex analytics. So you know that this is a system that can be trusted to store, analyze, and produce results for you on a consistent basis. Now, around the core of the core engine is the extension ecosystem. So Greenplum has many extensions, and by having a very strong core and then having a rich ecosystem of extensions, we can provide different value. We can provide value for cybersecurity, network traffic, geography, text analysis, and many different types of functions that operate around the core. So by leveraging this, we can continue to expand new analytical functions. We have added in Greenplum 7 new artificial intelligence functions that leverage open source technologies and allow you to benefit from integrating artificial intelligence with your data set. So let's talk about this and how it works. So Greenplum, like we said, is a unified platform. It allows you to bring all your data together into one environment and to consider your data across different dimensions. You can consider it as a relational database. You can consider it as an enterprise data grid or an enterprise compute grid, a data lake, a data warehouse. It's bringing everything together and allows you to process that data. And now we can also process and understand information in the format of vectors and matrices, which are generated output mathematically from artificial intelligence. So we can transform, and we can allow you to transform unstructured data, such as text, image, video, and audio, and it can be transformed into matrices and vectors using artificial intelligence that represent the underlying meaning. And that gives you a powerful search platform that you can drive to find information that you're looking for. And we are now transforming search from keyword-based search to meaning or semantic-based search. You can look for information based on the information content because the AI system that's powering this is converting this into the mathematical representation of what the data really means. So even if I was to store text and documentation data from around the world communications data being communicated in every language in the planet. And then let's say in Korean, I was to enter a search and I'm searching for information about railway transportation of plastic. We can find that in the African language, in the Russian language, in the Chinese language, in every language, because we are looking for information based on its mathematical meaning, not based on the words that were used. Now, when combined with the SQL layer, because Greenplum has a relational foundation and a SQL layer, it allows you to group by, aggregate, sort, and to filter data, and to really have an all-encompassing search platform that you can use. So how this works and how the artificial intelligence is layered into this is that we have a module called PG Vector. PG Vector is embedded in the new version of Greenplum, and it's a extension for Greenplum that allows you to store and to index vectors, otherwise known as matrices that were created from artificial intelligence to store the mathematical representation of the unstructured data. This is both scalable because of Greenplum's architecture and as well private because it's all done based on open source technology and based in your own data center. So when we look at this in a finer inspection, you can see that the Greenplum architecture is a parallel architecture. So all of your data, once you continue to collect it, will not fit on a single computer. It won't fit on a single drive. It needs to be spread across a network. And so the way our architecture works is we divide into parallel processing units and parallel storage units that can all work together to store, search, and analyze the data, and that with the central brain to organize the process and bring it back together. Now, in regards to artificial intelligence, one of the most interesting things going on is how it works with human language. So human language is people have tried to create rule-based systems for many years to parse natural language processing. But now we've discovered that actually language can be trained into the neural networks, into the artificial intelligence, and that those artificial intelligence can process language in ways that we never imagined. So within Greenplum now, we can link to the large language models, and you can process textual data in order to automatically categorize it into, for example, I'm working with customer complaints. What category of complaint is it? Is it a faulty battery? Is it a faulty warranty? What is the issue that we're talking about? You can automatically categorize data. You can summarize text and generate new text or translate text into a unified language. So we're extending the Greenplum platform to understand text, to search for text, and to be able to even transform text based on artificial intelligence. So that shows you where the artificial intelligence layer comes into the new version of Greenplum. But artificial intelligence is one aspect of what it takes to analyze data for actionable insights. There's also traditional business intelligence, and there's also machine learning and data science. And so in Greenplum's new platform, we provide a Python interface because Python is a programming language that can be used by data scientists and developers to communicate and understand and to work with the data. So the developers can now install the Greenplum Python onto their PC or onto their Mac, and they can write their code in Python, and it will automatically translate the requests from Python into the database language of SQL and process that data. So we've created a very rich and robust platform that allows Python developers to be very productive and to write code, functional code, and search code, and processing code, and query code. They can write these codes just in their local machine and then quickly execute that code against the database and leverage the power of a big grid of computers all processing that data in parallel. And one of the things that is absolutely critical for a platform like Greenplum is the performance. This is a hard driving platform that you can use to push your data results as fast as possible. And so it's of vital importance that we can optimize the performance of this engine. So Greenplum really is a fully featured database technology. Even though it can run on huge scales of petabytes, it also has a full suite of database index technologies. It has indexes ranging from traditional indexes such as B trees to new and modern indexes like block range indexes and PG vector. And we will go quickly into this and show some of the benefits of the new version of Greenplum. Greenplum 7 has improved its traditional B tree index as well. What is the purpose of a B tree? Is to search for one thing. You have millions of records and billions of rows or even trillions of rows. How can I find one row in just a fraction of a second? That's where an index comes in and allows you to find it. And Greenplum has tremendous now capability with indexes in SQL, and it's now 4.5 times faster with index performance, allowing you to do thousands of transactions per second in this database to process your data. We also introduced the BRIN, or BRIN index. A BRIN index is an automatic filtering technique to allow you to eliminate large portions of your data in order to process only the relevant pieces of the data. It stores the minimum and the maximum values for every thousands of rows and allows the database to know at a high level what range of values are in each block of data. That way it can quickly bypass and skip and find what it's looking for. And it has a very low overhead, as you see in this slide. It takes up very little space, it takes up very little overhead when you load data, but it can rapidly accelerate your queries. And speaking of accelerating queries, there's two key technologies introduced in Greenplum 7 that make finding and querying data faster. One is just-in-time compilation. This is an embedded compiler. So if you came from a computer science background, you will know what it means to be a code compiler, and that SQL is really an interpreted programming language, and that just in time we can use a compiler to generate optimized machine code in Greenplum 7 and make long-running queries execute much faster. We also have an optimization in data sorting, and you can imagine data sorting is involved in so many queries. When sorting is increased by 50% in speed, that makes Greenplum 7 much faster to query. And the other part of speed is how do you ingest the data? How do you get the data in? A lot of people struggle with analytics projects because they can't get all the data into one place. Getting all the data into one system, into one database, so that it can be queried across the platform is the first and most important challenge to getting actionable insights. By bringing the data together, it can be analyzed quickly inside of a system. So now with Greenplum 7, we have faster data loading with multi-threaded and compressed GPF-dist agents that take up less network bandwidth by 60% and improve the speed of loading, which was already quite fast. In fact, I think you're going to hear later today from one of our partners and what they were able to do with hardware and how we worked together with Samsung on their hardware architecture. And in that architecture, we were able to see 100 terabytes an hour of data loading on a system. So really you can load a lot of data. And once the data is all consolidated into one place, it becomes very important that thousands of users can all access the system at the same time. How do you create a shared environment or a data lake environment or an enterprise environment for your data that can be shared by all the departments and all the groups, and they can all leverage it on one platform so that you don't need to make many copies of the data? And that comes to resource management and resource control. So Greenplum 7 has a new and improved resource control system that allows you to track every resource in the system, from the number of concurrent queries to the CPU levels, the memory levels, and even the disk I/O levels. You can control it with a fine-grained granularity and ensure that all the different business departments and business groups get the access and the resource levels that they need. One of the new techniques that we offer is to prioritize short queries over long queries. This makes for a very responsive system. If a query is running for an hour and it takes an hour and 1 second, nobody is going to notice that, or nobody is going to complain. But if a query is running for 1 second and takes 3 seconds, people will know that. So it's very important that the short queries that come in get the priority and can be given execution faster and on top of the longer queries. Now, managing the system should be seamless so that you can be confident and that you can push more data and that you can push more business projects onto the platform. So we've done a number of things to make the system easier to manage. And a lot of it starts with how we manage the metadata. You have data and you have metadata. Metadata, which is data about data. And this is what allows the database system to understand and to work internally. So we have introduced in Greenplum 7 automatic vacuum, which will take care of your data catalog or your catalog and allow it to automatically clean any unused space and to automatically keep the statistics up to date. And this keeps for a more autonomous running system that requires less maintenance that you can use. We also have improved the speed of the user analyze when it comes to compressed data by creating more efficient sampling of variable block size compressed data, which was a very difficult challenge now that you can really keep your statistics up to date, and you can even use multiple columns in your statistics in order to correlate different columns that have a relationship between them. And another key feature in Greenplum 7 is the unique and primary keys. With all huge datas, we can operate as if it's a small data. We can create unique constraints, which means that across the whole system, we will guarantee that no duplicate value is entered for a specific key. For example, if you had a citizen ID and a table of people, we want to guarantee that always only the unique citizen ID is entered into that data. And it can be done across a wide grid of systems and can be done across compressed and uncompressed data now in order to help you to maintain data integrity and to make sure that you're not wasting time trying to research the consistency and the integrity of your data. It's guaranteed and enforced. And we make it easy to transform your data internally in terms of its own storage. Once this data is all collected, it has a huge weight that the DBA must manage. Petabytes of data has almost a physical weight that needs to be moved from place to place. And these tools give you the DBA the easy access to alter the data and to recompress the data and to resort the data into more efficient formats so that over time you can squeeze that data into less space and use more of your hardware for other work. So we give you these flexible tools to move the data around inside the system at high speed and without any locking or with less locking and with less complication, that you can do it seamlessly. And then you may need to merge data. So in this case, this example here, we have a sensor table, and the sensor table has a sensor key. If the sensor key is already present, it needs to be updated. If it's new data, it needs to be inserted. So how can we merge data with what we call an upsert command, which is a combination of update and insert? So we make it so that you can merge that data and have the integrity and integration. And then we give you the ability to replicate the data, which is a new capability in Greenplum, that you can now replicate the entire environment from one data center to a second data center. Because once your business case becomes so important, once your company depends on this platform, it's very important you have a plan. What if the entire building is not available? You need to be able to have an entire another copy of the data as it's updated, replicated to another site. And we now offer multi-data center replication and protection to enable you to protect your data as much as possible. If you create a segregation, a hard segregation, some people will create multiple environments of Greenplum. We give you the ability to query between the environments now with query federation. You can access Department 1's data from Department 2. Even if they create completely isolated and separate systems, you can still query between them and again, avoid data copying. And you can manage your environment, you can manage your compute using the VCF, the VMware Cloud Foundation. We can deploy all of the software for Greenplum as virtual machines and use a abstracted virtual storage to store the data. And that way the Greenplum layer is really just a compute layer running on top of a separate storage layer. And that enables you to separate your compute and storage and to scale them independently. Or you can go with the traditional approach on bare metal, and both are available. Security is always improving, and now in addition to role-based access control, object-level access control, table-level access control, column-level access control, we now provide even row-level access control. So if you have certain elements of data, certain rows of data that should be only visible to certain roles or certain people, that can be filtered so that seamlessly the data that's returned from analytics and reporting is different for different people, depending on their role and what security level they are at, what clearance level they are at. So, as you can see, we have packed Greenplum with innovation, and we really want to see customers push Greenplum to make a business impact. And we are going to continue to push more features into Greenplum starting right now. We're not resting now that Greenplum 7 came out. And so I want to share with you 3 or 4 key highlights of what is our new focus. One of them is automated system health checking and graphing. Sometimes the DBA or the system manager will get a question from their users. Why is the system slow today? Now the DBA or the user administrator needs to know, is it slow or does the person have wrong information? So we are providing ways to track the performance of the system over time and to measure your own performance through graphs and compare it to your resource using what we call canary queries, where you can schedule your own workloads to run and time and graph them. This really empowers the system manager to know the health of their system and to be able to be confident when users come to them, yes, my performance is good. So if you're giving me a complaint, it must be your problem, not the system problem. And then we're providing more performance optimizations. We'll be providing hints to the optimizer to allow the query writers and the administrators to tune and to tweak the queries and to provide hints what to do so that in the case that the developer knows better, they can hint the system. And as well, for external data, where we combine Greenplum data with data in other databases or data in S3 or data in HDFS, we're adding more statistics to that data so that Greenplum not only is clearly aware of what data is living inside of Greenplum, but Greenplum is clear what data it can connect to and what are the detailed attributes of it so that it can merge data both in Greenplum and in the federation of all of the other systems in the enterprise that need to be joined and analyzed together. And then another very important project for us is data flow, data movement, how to capture changes from system 1 to system 2. We call this change data capture. We want Greenplum to be able to publish events. Every time any data is changed in Greenplum, detect the change and publish it into a message, publish it into Kafka or publish it into RabbitMQ, and be able to track every single change and use those changes to mirror these data into other technologies, to mirror it into another Greenplum or to mirror it into MongoDB or to mirror it into Postgres or to mirror it into anywhere. And at the same time to be able to ingest data, let's say from Oracle, and be able to import data from Oracle so that you can consolidate everything into Greenplum. So this is about data flowing and capturing changes and bringing data together into different layers. On the topic of geography, we have a very interesting feature R&D about how to do a geographical join. The example here is, for example, with Uber. Now, if you have one set of people who are car drivers, taxi drivers, and another set of people who are passengers. How can I locate all passengers within a distance of the driver? How can I do a geography join where I can map the whole world and locate who's close to who? This is a very interesting problem that can be used in many industries and governments in order to answer questions that are very important about where things are and who's where and what is where, so that they can do business problems related to geography in more enhanced ways. And then another project that we're very excited about in relation, it's not quite artificial intelligence, but I would call it machine learning. It's still machine learning, but it's not based on neural network technology. Because in actuality, there are quite a lot of benefits to doing machine learning as well as artificial intelligence, and especially when you have very structured data. So we are introducing a robot inside of Greenplum that can help the user to train machine learning models so that if they have data and they know what they're trying to predict with supervised machine learning, that this robot will guide the user and help them to create the models that can be used in a production basis and can be deployed immediately in a production basis. So although these algorithms and capabilities have been in Greenplum for many years, what we found is we need an automated agent to help users to use the system and to run experiments and to find out which algorithms and which techniques will be useful in their case. So you can leverage this in order to accelerate your data science and accelerate your data analysis with predictive analytics. So when you look at the platform together, we're making a platform of intelligence that allows you to bring all of this data together to gain insight and intelligence about the data and to create actionable outcomes. And it needs to have many features. It needs to understand all the different types of data and to be customizable to your own data. It needs to understand not only transactional data, but it needs to understand text and language, and it needs to understand location and geography, and it needs to understand meaning of images using matrices and vectors, and it needs to be able to run machine learning algorithms, supervised and unsupervised, and it needs to be able to be expandable with coding languages like Python and Java and R. So really that we can give you a convenient and powerful platform that you can drive your business outcome with this platform. And so we're really excited to be here. I'm really excited to be here and to meet our customers and to see what they're doing with our platform and to get more excitement into me when I see what they're doing and what they're accomplishing, and makes me want to build more features and more capability. So with that, thank you very much, and looking forward to talking with anybody who's interested during the breaks.